Okay, 7th graders, we are moving on to section 2.7, greatest common factor. Okay, so this is exactly what it says, that it's the greatest, so that means the biggest factor that numbers have in common, that they share. Okay, so anytime that you're kind of wondering, because you're going to have least common multiple next, and so it does get kind of confusing between the two different definitions there. So there's two different ways to do this. So the first way is using a list to find the greatest common factor. And so what you have to do is you have to take your numbers, and we have 3 in this case, sometimes there's just 2, and you just make a list of their common factors, like what numbers can go in there. And going in order is going to make that easier. So I kind of go through my numbers, like 1 can go into 24, 2 can go into 24, 3 can go into 24, 4 can go into 24, 5 can't, 6 can, 7 can't, but 8 can, 9 cannot, but 10 cannot, 11 cannot, but 12 can. And usually, once you hit that halfway point, then the only other factor would be 24. Okay, so now we're going to do the next number, 36. And again, you kind of go through those numbers. So think of your factors. 1, 2, 3 can go in there because 3 times 12 is 36. 4 times 9 is 36. 6 times 6. 7, 8, not 9 times 4. 10, no. 11, no. 12, yes. 13, 14, 15, no. 16, no. 17, no. 18 is your halfway point. And then 36. Okay. And then our next one is 48. So we've got 1, 2, 3 can go into 48, 4 can, not 5, but 6, 6 times 8, not 7, but 8 can, not 9, 10, 11, 12 would be the next number, not 13, 14, 15, 16 can go in there, 16 times 3, 17, 18, 19, I think the next one would be 24, that's halfway, and then the last one would be 48. So you guys can see. And so we are looking for the biggest factor that they all have in common. So you should take a look at our list here, and look at this. 16 is, but the other ones don't have 16, so 12 looks like the biggest factor that they all share. Okay, you can look like 24 is both of these ones, but not of 36. So the greatest common factor of those 3 numbers, the greatest common factor is 12. Okay. So that's how you use the list method. Now it's good with factors that are small or medium sized, and that you can think of all the factors, but you're going to encounter numbers that are not that nice. So we're going to use prime factorization, which you just did in 2.6. So when you do that, you need to factor both numbers just like we were doing before. So for example, 2 and 30, 2 and 15, 3 and 5. So that's one of them. Okay. And I'm going to factor 45. So I think of 5 and 9 maybe, and then 3 and 3. Okay, so now what you're looking for is you're looking for any shared factors. So any factors that they have in common. So they have a 5 in common, and they have a 3 in common. Okay, so because they share a 3 and a 5, the greatest common factor is the product of their factors. So 3 times 5, would give you 15. So the greatest common factor is 15. And double check, does 15 go into both of those numbers? And it does. Okay, so now I'm giving you a problem with 4 numbers. So we are going to have to factor all 4 of these. And don't be alarmed with the bigger numbers. Just try to cut them in half to try that way first. Okay, so I'm going to divide by 2. So 2, half of 500 would be 250. So this would be 252. Okay, you can split that again, and I get 2. Half of 250 would be 125. So 125 would be 126. Go again, would be 2. Half of 120 would be 60, so that should be 63. Half of this would be, I could do 7 and 9, and then 3 and 3. That one got kind of long. My pen is dying on me. Okay, so now I'm going to do 132. I know I can divide by 2. Half of 130 would be, half of 120 is 60. So it'd be like 66. Yeah, 66. Takes me a little bit to do this math in my head sometimes. 33, 3, and 11. Okay. And I know I'm done when I get to my prime numbers there. So now, let's see if I have some other colors. I'll just use a pencil. Okay, I'm going to do 96. I can divide it by 2. 2 and 48. I could divide it again by 2. I get 24. 2 and 12. 2 and 6. 2 and 3. Okay, and then I do 60. And I get 2 and 30, 2 and 15, 3 and 5. Okay, so now I need to find numbers factors that they all share. So I'm going to start with, I see that they all share at least a 2. So a 2, a 2, a 2, and a 2. Then I see that they share another 2. You have to make sure that all of them have the greatest common factor. And then I don't think I can do a third 2, but I do notice that they all have a 3. Let's take one of those 3s. Okay, so now what we have to do is we have to multiply those 3 factors. So we are going to multiply the 2, 2, and the 3. So 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. So the greatest common factor is 12. Okay. Next one, I have 40 and 56, so just 2. So let's do 40. 2 and 20, 2 and 10, 2 and 5. Let's do 56. So I think of 7 and 8, 2 and 4, and 2 and 2. So what do they have in common? Well, it looks like they have a 2, and a 2. So they have 2 times 2 times 2, which would be 8. So the greatest common factor is 8. Which, if you think about it, 8 does go into 56, and 8 goes into 40. So looks like we're on track. Okay, this is another big one. 252. I kind of split that one up here, so that would be 2 and 126, 2 and 63, 7 and 9, and 3 and 3. And if I did 180, remember yesterday I said we could do like 18 and 10 if we wanted to make that one easier. then this would be 3 and 6, 2 and 3, 2 and 5. And you can tell, like, if my work was really messy, that would make my job harder. So I'm trying to keep it nice and neat. 96, we just did that one up here, so I can do 248, 224, 2 and 12, 2 and 6, 2 and 3. And then the last one is 60. We did that one before too. Makes our job a little bit easier if we have a reference. 2 and 30, 2 and 15, 3 and 5. I'm making a video, okay? So now I've got to find their common factors. Do they all have a 2? Sure. Okay. Do they all have another 2? And it looks like they do. This one was just hidden for a moment when I was looking. Okay. Do they all have a 3? And if I look through, they do. So 3, a 3, a 3, and a 3. And then, let's see, do they have anything else? I was going to see if they have a 5, but 96 and 252 doesn't have a 5. This one doesn't have another 3, so I think that's my end. So now I need to take and multiply those together. So 2, 2, and 3. 2 times 2 times 3. 2 times 2 is 4, times 3 would be 12. And there we go. Okay. Last example here, it's our word problem. David is making favor bags for his birthday party. He has 50 confetti eggs, so 50 eggs. He has 30 noisemakers. So what is the greatest number of matching favor bags can he use to make all of the confetti eggs and noisemakers? So you could do this 2 different ways. You could list the factors if we wanted to do that. 30 and 50. So if I did 30, my factors would be 1, 2, 3, 4 doesn't go in there, 5 does, 6 does, not 7, not 8, not 9, 10 does, and then 15, and then 30. And then we could do the same thing with 50. We know 1 does, 2 does, 3 does not, 4 does not, 5 does, 6 doesn't, 7, 8, 9, 10, 11, 12, 13, 14. I think the next one would be 25, and then 50. So what is their common factor there? The greatest common factor, it would be 10. Okay, and then we could also do it the other way. So let's factor this. 2 and 25, 5 and 5. If I factor this one, I could do 3 and 10, and 2 and 5. So what are their common factors? Well, they each have a 2, and they each have a 5. So my common factor would be 2 times 5, which would be 15. So they can make 15. We'll back up. Let's check that math again. 2 times 5, which would be 10. So they could make 10 bags. There would be 5 confetti eggs in each bag and 3 noisemakers. But that would be the greatest number of bags they could do using all of the favors. So you can kind of think of it in 2 different ways.